The next topic is engineering and computing in the Arctic, challenges and opportunities. The speaker is Kenneth Ruud from the Arctic University of Norway.
Thank you very much, and I would like to start by thanking the organizers for giving me an opportunity to come here, and in particular, of course, to Stefano. So this will be a little bit of a different talk. I want to take you to perhaps a part of the world you don't know that well, and give you a chance to see the opportunities that are there, but also what kind of challenges there are that I think also will have an impact in terms of modeling and in relation to the challenges in engineering. And when it comes to computing, I hope I will be able to convince you there are not really any challenges, just opportunities. So first perhaps about the University of Tromsø, the Arctic University of Norway. We're about 45 years old. We're located about 350 kilometers north of the Arctic Circle. This means that in 3 weeks' time, the sun disappears, and it comes back in about 2 months later. But that gives us it has its advantages, as I hope to show you later on. We also have 5 campuses from Tromsø to Kirkenes. The distance, since this map may be a bit misleading, is about 1,000 kilometers by car. Then the good thing is, of course, one of our campuses is Bardufoss, where we have a small pilot school, so this could be an advantage as well in terms of the way we're organized. Anyway, we have about 3,000 students, 3,000 staff and 12,000 students. So it's a full-fledged university. We cover all fields of science. We have defined a new strategy, which has several elements. I'm going very quickly through this. This is not that important. Energy, climate, society, and environment, technology, and you see some of the things I'm going to address to you. Health, welfare, quality of life, society development and democracy, as well as sustainable use of resources. We'll skip quickly over this one. Now, in order to operate in the Arctic, you can't really be isolated. At the University of Tromsø, the Arctic University of Norway, we are in charge of about half of the projects that the Research Council of Norway has devoted to the Arctic. But nevertheless, we need collaboration, and we have established a Tromsø High North cluster with local actors from industry and from governmental offices, including also the University Hospital, including also oil companies, Aker Solutions, Statoil, Eni, and so on. So in a sense, Tromsø can be your one-stop shop in terms of addressing Arctic issues. Now, what are the opportunities in the Arctic? The upper map to the left there, that is the so-called northern sea routes. As global warming is coming, the ice is retracting, and that gives the possibilities, if it continues, and we're not able to stop it, for new pathways of actually shipping goods. Nevertheless, there will still be ice there, and that will create new challenges in terms of operating safely. Another thing to notice about this map is the vast distances. As I said, from Tromsø to Kirkenes is 1,000 kilometers. Look on the map, it's a very tiny part. So if there is an accident, rescue is nowhere near. There is no way you can easily rescue someone. So safety becomes an enormous concern. That also means the properties of materials really has to be top-notch. But at the same time, there are vast resources. Petroleum is one resource, minerals another opportunity, and of course the vast opportunities that are in the living ocean. Fish is one example, but also the fact that we can harvest living organisms from the cold sea to generate, for instance, new medicines. And an interesting part about the Arctic Ocean is because it's, as I guess you could realize, it's quite cold, and that means animals and life forms has to adapt to a much lower temperature. So they have to function with much less energy, and that gives them unique functionalities that we perhaps don't know how to exploit, but we can exploit in terms of energy. So there's a lot of opportunities, but there is also a lot of challenges, because you have to operate in these conditions. And ice packs, moving ice packs, will be a huge strain on whatever material you're using. If you're going to drill down to oil with an oil platform and the ice pack is moving, what happens if you actually break an oil pipe in terms of the environmental pollution you have? How can you gather oil? So there's a lot of new challenges in terms of engineering that need solution. I think modeling in this respect has a lot to contribute, because we don't have to do the real-life experiments that really can ruin everything, but through modeling and through sophisticated models, we can really make great advances. And of course, these are also complicated computational models that we need to address. So there's a lot of opportunities, I think, for this community to contribute to making the opportunities in the north coming alive. This is just, again, to show you a little bit of the opportunities. This is a map showing the resources in the Arctic on the left in relation to minerals, oil, and on the right in terms of marine bioprospectation. Another engineering challenge is, of course, that, I mean, we do a lot of farmed fish. But the best way of having really clean waters, avoiding disease in the fish, is, of course, putting it out into the open sea. We have much better circulation of water, but then you have, once again, the hostile environment, huge waves, 10, 15-meter waves, ice potentially. So how do you make sure the fish don't escape and that the equipment survives these harsh conditions? So once again, a lot of opportunities and new challenges if we're going to exploit these rich areas of our planet. So this means when our Department of Technology is looking into how to understand and how to evolve these areas, safe operations is really a key element. We need to be aware of the sensitive environment and the rich marine resources, at the same time as we need to be aware of the fact that we have rough and unstable climate, there's an extreme cold, the meteorological conditions, icing. Ice can be extremely heavy when it piles up, and it can do very quickly in a very cold climate with a lot of spray water, say. Geography, as I mentioned already, the darkness in winter, remote distances, long distances, so rescue operations is far from trivial, so you really want to minimize risk as much as possible. Also because there is very little population in general in the north. So we have 5 areas of operation where we focus on: safety, social safety and environment, automation, process and gas, maritime operation, aviation and pilot. And I have listed at the bottom there various challenges and issues that the department and our university is engaged in and interested in. Just give you one example of how we then try to link various technologies together to face these conditions. So by using microwave technology and camera-based technology together, we want to then develop decision support systems for early warning of, for instance, the risk of icing. So you can see really here the amount of ice you can quickly gather on a ship that could just weigh the entire ship down with its cargo, with its crew, and how you need to deal with this. You can see it's still low tech in terms of getting rid of the ice. But of course, having also here materials that can stand the strain is really, really important. And once again, I would advocate to your community, as a modeling community, to take this up as an interesting challenge, both in terms of understanding the process of icing, but also what is required of the materials. We have some opportunities ourselves in terms of dealing or understanding these problems. So we do have advanced simulation laboratories. We got a new technology building where we then have, for instance, simulation labs, including motion activation for training captains on ships, understanding how to operate a ship in harsh conditions, so doing the safe operations, so minimizing risk as always. And also the representative of the European Commission mentioned big data. We also then have big visualization screens. We can really get high resolution processing very, very fast. And we do, in relation to material science, also have a center of excellence in theoretical and computational chemistry and other modeling activities. I'm not going to go into the details here. But then I want to switch to computing, which is, of course, central to all of you here, and ask a question which I guess, well, maybe I'm a computational scientist myself, and I don't normally think about these questions, but it's actually quite interesting and quite useful. So why is the development of server rooms and computing centers important? And it's worth realizing that actually, although we now talk about computing can be a way of solving energy resources, 1.3% of all electricity use in the world was in 2010 caused by the computer centers. And many of these are actually powered indirectly by coal plants that produce the electricity. Another interesting fact is, of course, to cool down these processors, because they, of course, become warm when you do computations, is that you normally would use air cooling, and that requires additional energy. And, of course, you get a lot of heat, but there are very few facilities that actually can utilize this heat. And perhaps there has been too much focus on reducing the power usage effectiveness instead of the overall power use of a plant. Now, and that's where coming back to the benefits of living in the Arctic, because there are clear benefits. This is from just outside Tromsø. You have 9 months of winter, and then you have 3 months of poor skiing conditions. So Tromsø, the average temperature year-round is 4.4 degrees. But it's a very temperate climate, so in January it's -5, in July it's +12. But this means we need heating 11 out of 12 months a year. And this we have instead then chosen to use or to take into as an advantage, because there is now coming new technology in terms of computing where you cool with hot water. This allows for efficient heat recovery by using the heat generated in the computer to heat buildings. Of course, that depends that you have a building nearby which can actually use this heat. It also requires specialized server design, and that the exit temperature from the computers are around 30 to 60 degrees Celsius. But there are actually many vendors that can provide this solution. I could possibly have forgotten someone in the list here. So this is a technology that is now used. It's used in many computer centers also in Europe. But still, using the excess heat is non-trivial. We were very fortunate in Tromsø in that more or less when these technologies became available, we were allowed to build a new technology building. So we can actually make this building adaptable to this technology. So what we then can offer is the fact that in Norway, 98% of all the energy we produce are from hydroelectric power. So it's green energy to start with. We have free cooling. We can reuse, actually, as I said, because we need to heat the buildings 11 months per year. We can reuse up to 80% of the excess heat from this facility. And, of course, compared to other industry, there are no ethical or environmental concerns with respect to computing. Now, of course, the success of this, as I said already, depends on mass production of water-cooled servers. So this is my plea to the vendors: please continue to produce this technology, and that we could integrate it with an existing building, and that it's, of course, stable technology as well, so that we do have the secureness in terms of getting our computation through. And to some extent, if you like, the electricity price don't have to drop too low, but I don't think this is a problem. So at least from our point of view in Tromsø, we actually have a win-win situation where we can use these facilities and heat our building and really have a green computing center. So I have several hats. So this was now speaking from the point of view of the University of Tromsø, the Arctic University of Norway. I'm also the chairman of the scientific steering committee of PRAISE. PRAISE is the Partnership for Advanced Computing in Europe. So it provides access to Tier 0 computing resources to researchers and industry worldwide. It's free of charge. It's now currently been running for 5 years. It consists of 25 members altogether over Europe, of which 4 hosting members donate the computational resources of a total value of 400 million euros. So in these 5 years, we have granted 8 billion hours of computing to science and industry, enabling 303 scientific projects from 38 countries, so much more than we have member states, as you note. And also 20 SMEs have been given access to the PRAISE resources. We also offer training for running on these Tier 0 facilities 125 training courses, and 2,700 people have been through our training programs. These are these Praise Advanced Training Centers, PATSI. We also have a SHAPE program, which is particularly targeting small and medium-sized industries to enable them to use these kinds of infrastructures. The sole criterion for getting access is excellence in science, and that it's open research. So meaning that you have to publish this. But apart from this, whether you're industry or whether you're academia, you're welcome to use these resources. I would strongly encourage you to have a look at this. We have preparatory access to help you get started on the machines, and then you can get really large allocations. The biggest allocation we had was for 140 million CPU hours, core hours for a year. So you can really do large-scale computations. So I think then I will round off ahead of time, so I'm a little bit proud of myself. If you're interested in learning about the opportunities that there is in the Arctic, I would encourage you to visit this Arctic Frontiers conference. It's organized every year, about 1,000 participants, high-level politicians, and industry and researchers. It's different topics every year. Next year it's climate and energy. And finally, I would like to, just to entice you further to visit Tromsø in the dark period, I'll give you some relativistic chemistry by the Northern Lights, and thank you very much for your attention.